Hi, my name is Peyton Crenshaw, and I wanted to just go ahead and explain my Lab 3 black hole. So, starting off with the purpose of this lab is to calculate the mass of the black hole using the star's motion, and then also to find the initial velocity of the ship when it leaves the planet. So, starting out, I wanted to just talk about a few fundamental physics principles. The first one being Newton's second law, the second one being the law of universal gravitation. The next one being the velocity update formula and the position update formula. And then also here are just some components of net force and momentum change. So I want to dive a little bit deeper into the objectives and the assumptions that we have when it comes to the two parts of the lab. So the first part of the lab is going to be finding the mass of the black hole. And we're going to assume that the net force on the star is because of the black hole. And we're also going to assume that the time of everything is going to be 1 day. The system is the black hole and the surroundings are the star. And then for the second part of the lab, we're kind of trying to find the initial velocity in order not to crash. So with this, we're going to assume that the ship is orbiting the black hole, and we're also going to assume that the launch of the ship is in the same direction as the planet's motion. Lastly, we're going to assume that the net force in the ship is due to the black hole and the planet's gravitational pull. When it comes to the system, the ship and the planet are both the system, and the black hole is the system for both of those. However, for the ship, the planet is going to be the surroundings, and then for the planet, the ship is going to be the surroundings. So first, starting out with part one, a lot of this lab was through GlowScript. So I just wanted to talk about some of the initial conditions. So the mass of the star is going to be 2e30 kilograms. And then the day or the time, like I said before, is going to be 1 day or 86,400 seconds. So we went ahead and entered that into the GlowScript code. So next, which kind of gives us like our final things, um, you can see right here that the momentum formula is in my code as well, which is star period m times the final, and that's like to find the momentum initial and the momentum final. And then you can see Newton's second law is also in there, which is delta P and delta T. Um, and then we also have some more of the um, net force equations that are also put in there, and I put arrows to those so that you can see those clearly. Um, yeah. So to find the results of the first one, you can see that it kind of gives you like a 3D diagram, and the mass of the black hole is going to be 2.4 E34. And then the magnitude of everything is also in there. So F net parallel, and then F net perpendicular are also right there as well. So then for part two, these are also the initial conditions. So the ship mass, the planet mass, delta T, which is the time, and the gravitational constant. And then for part two, this kind of goes a little bit deeper into the code. Of course, again, I put where you can see the different equations that are actually in the code so you can further understand the code if you were to be looking at this for the first time. So, for example, this is the position update formula and the velocity update formula, and then the universal gravitational. So then here are the results of part two, and I got all of this through the code. So the initial velocity of the spaceship, and then the distance of the ship from the black hole. And then to sum everything up, we kind of did like the what if and the conclusion of everything. So question one, how is the net force and its parallel and perpendicular components different from the rate of change and momentum and its parallel and perpendicular components? So the overall direction of the momentum is equivalent to the net force. So the rate of change of the momentum is needed to calculate the parallel and perpendicular component. So therefore the net force and the rate of change of momentum is the same. And you can also see this through the code. And then question two, what initial velocity would your spaceship need to have in order to enter some kind of orbit around the black hole? And for this, my answer is the gravitational force of the planet would have to be passed by the initial velocity. So this would mean that the y component of the velocity is greater than the x component of the velocity in order for the spaceship to enter some kind of orbit around the black hole. So yeah, that's everything. And then also just to cover one more thing, talking about ways that there could be error within this lab. One main way is always human error. There could be calculations. You could type in one wrong number, and that could alter everything in your lab. So, error is really big in any lab that includes humans. So, yeah, thank you guys so much for watching.